Can you?
Yeah.
I would like to confirm the time in your I guess in your phone. That what's the time right now?
Sorry?
What is the time right now in your phone?
It's 9:10.
Yeah. What time? Sorry.
It's 9:10.
Right. Now, me also 9:10. Yeah. Now, starting tomorrow, I will be protecting your tuition time. Yeah? I'll be calling you 5 minutes before so that you will start setting up. Then we can start on time.
Okay.
Do on your phone. If I cannot reach you through your phone, I'll be calling, yeah, not WhatsApping. If I cannot reach you, then I'll be reaching you there. Okay.
Okay.
Now your video is right.
I already put the homework in the Jamboard.
Wonderful. Let me confirm that it is paid. This I see a page 5. No, yeah. I'm not sure what's in page 5. Yeah, it's very unclear. Yeah, I only see a page 5. So, what do you want me to see in page 5?
The picture.
Which is it's like the no, I'm unclear which question is this. This is not the one that you selected for yourself. Which question is this then?
Huh? Where's the picture go? Oh my god. I took a picture and I put it in the Jamboard.
Okay.
Then it's gone.
Fix your internet, I guess.
No, I took it yesterday, so I have no idea where the page is anymore. What?
Can we go to video? Let's go quickly. Yeah.
Okay.
All right. You show me. Yeah. Show me something, Anish. What do you want me to see?
Yeah. I can't believe this, man. I have found homework.
Now, for this, did you take this from, sorry, did you take this from your paper or from my paper?
Sorry?
Do you have answer key for this one?
For the question that I did.
Yes.
Do
you have or don't have? Is it from your paper or my paper?
The question that you put, oh no, I don't have it.
It's from your paper, is it?
No, it's from yours. So I'm assuming you have it.
Right. Now, if it is from my paper, which paper would that be?
I don't remember. Let me check the drive.
Okay.
It was from 2 papers, I believe.
I'm going to help you organize starting this week, yeah? Right, so that everything becomes faster. That's my only goal, yeah?
Okay.
Right. Like this, I'm not sure whether you can reach your goal. So I'm gonna help you organize. The working itself is fine. That one I like. I think the organization around your work is what we need. Now you show me question 8, put it there, and then question 8. Yeah, question 8, wonderful. Right. Then you show me question 12. You haven't checked your question. You haven't checked, so we are very slow. We cannot do this. We cannot do this. Okay.
Sorry?
Because you haven't checked that, we don't know what to do.
I found BAT, I don't know how to pronounce, BEATTY, secondary school, and Fairfield.
BT.
Yeah.
Saying BT. Good. Yeah, that's a start. That's a start. Right. Is it the Sec 4 prelim?
Sec 3 A math. I don't have Sec 4 math papers. You didn't give the 3.
Gonna fix that now. Yeah. So just in case you want 3 go, you will have. First, gonna fix the Sec 4 thing. I share with you Sec 4. The Sec 4 one is not Sec 4, it's an O-level AMAT. So just check first in your Google Drive that you have O-level AMAT.
I do, yeah, okay, yeah.
So it turns out it's not Sec 4. Feel free to use the latest one, 2020. I say don't use, that's no longer true. Why don't I just rename that, right? Okay, that was my mistake. Right, so we use 2020. And all my papers should have an answer key. Go to folder 2020. I want to show you something.
For the Sec 4, right?
O-level even, yes.
Okay.
Right, if you scroll down in the folder, you will see some files with the heading X, X 2020, for example. Can you see that down?
Yeah.
Those don't have answer key. That's very rare in my paper. The rest have. So you don't touch that. You touch the ones without X. Yeah. Right. So O-level, the Sec 4 one, Sec 4 is useful when you want to practice the Igolo. Right. Sooner or later we have to deal with that. Okay, yeah. Good. Now, we cannot spend time checking your answer right now. Right. So let me just see that you have the question 8, question 12, and then show me the comparing coefficient. That means go up. Video go up. Wonderful. Gonna copy that. Okay. Whenever we see a nice number, we are a little bit heartened. Yeah. Heartened by comparing coefficient A equals to 6. Yeah, that already makes sense. That's 3 marks. Sorry. What else you have? What else you have? Show me. In the 8B quickly.
8B is here. Wait, what?
8B, no, 8B is not there, right?
Yeah, that's where the issue comes in. The thing is, I took a picture of all this and I put it in the Jamboard and in page 6. That's where I originally put it. But apparently it's just not there anymore.
Okay, right. So you don't have the paper, that's what you're saying.
Yeah, but I didn't have any problems with it. So I think it's correct.
No, you haven't checked. So yeah, you don't have the paper anymore, is what you're saying.
Yeah. Because I did on Saturday and I don't know where it is now. But I found this person.
Starting tomorrow, we will discuss less on the question because I would like you to read yourself. So this is the first time I ask you to read yourself and you do not have the benefit of discussing with me. All right?
Okay.
Right. So this is where you start to see, are you mature enough to handle it yourself? However, as with all persons, my students are going through exam training, the reading is a must. So that one, you don't have any option. Even though you're doing it yourself, you will read first and then you will allocate the minimum time. The minimum time is 1 mark, 1 minute. That's super minimum. It's supposed to be 1 mark, 1.5 minute mark, right? But that is how we justify spending a lot of time in reading and planning, right? This one thing I can promise you, as the topic grows, reading becomes even more important. Not let's just say the exam pressure will defeat you. That one I'm currently uncertain. And reading is the best antidote to that. That I can promise you to be more and more relevant as the topic grows. Okay? That means when the exam extends beyond 30 marks. Okay? However, you will already feel the effect when the exam is around 30 marks, which is what you're practicing right now. Okay?
Yeah.
So regarding reading and then doing it with minimum time, it is not an option, right? However, you can choose to separate them. You can choose to read first, leave it for half a day, and then you do that. But that's up to you. You don't have to do them consequently, just like that. Okay? Now, for your tomorrow's 30 marks, right? You will choose yourself, you will read yourself, you will do yourself, and let's see what happens, right? Are you intending to include Trigo or not yet? This is totally up to you.
Maybe not proving, but I'll try the drawing ones, the quadrants.
Good. Because this week we have to enter. If not, then we cannot continue to the next. We haven't touched any new topics. You're just improving your own one. Doing good so far. Okay, so at least include 1 or 2. Okay. And since you're taking it from my paper, because your paper is almost done, right? In those topics, then the last thing that you will do is you will check. Right? You will check the answer key and then mark yourself. Okay. When should I comment on the organizing? I'm not sure today or today. I'm itchy. What? Sorry.
What do you mean by organizing?
You keep losing your paper after 1 day.
Oh yeah, okay.
So we just prevent that from happening. That's all. As in, whether the paper is lost or not, we will have it and we will mark it, and it will be stored properly for your future reference. That's what organizing means anyway. Whether on paper or on digital, that is our goal.
Okay.
So I don't want that to stop you from reaching your goal. I would like to intervene, right? This one I would like to intervene and make you better in that regards. I suppose I don't mean organizing your table. That I suppose that's not what I mean. Right? I suppose what I mean is organizing your work for future use. Okay, so today I'm very itchy to talk about science, right? Not yet on the new topics of AMAT because you're still doing well on the old one, so it seems, right? Now, are you sure you have no particular question on the homework?
No.
All right, then let's assume that there's no problem yet. I will look at it later, right? However, tomorrow when we meet, you would have marked your exam, marked your homework already using the answer key. Okay.
Yes.
Right now, metal. Let's go back to metal, right? And if you have time, we will go back to physics so that you can continue your reading. Okay. Okay. Please share your screen. We'll talk about the metal slides. Right. Go to the last one that we talked about. I hope you remember, right?
It's over here, right?
Around there. Good. Around there. Right. Okay. So we were talking about the 3 reactions from your slide, and then I add one more. The last one I talk about with you is the homework, the 4 combo, right? The 4 combo. Now, let's start with you telling me what's the reactivity series, and I'll write it down on your screen. Right? Please allow annotation.
Okay.
Right. So you tell me what's the reactivity series that you have in your memory.
Yeah. So we have group 1.
Okay.
Group 2.
Right.
Group 3.
Yeah.
Carbon.
Very good. First time you got it right.
Yeah. So zinc, iron, lead.
I write down as the proper symbol. Don't mind it.
Then we have hydrogen.
Then
we have copper.
Yeah.
Silver, gold.
This is out of your memory.
Yep.
I teach you one extra thing, the mirror image, right? What does the mirror image contain?
The ions.
Of the exact reverse order.
Yeah.
So where can we find sodium metal in this reactivity series?
In place of hydrogen. No, sorry, what?
Yeah, that you asked, you didn't make sense. So where's sodium metal in the reactivity series?
So wait, what group is sodium?
You can always refer to your periodic table if you don't want to memorize, but do that quickly. Right? I'm asking in the sense that you should know what you do in exam. Let's imagine it's exam. I still can't believe you don't remember it, but that's you, right? So at least remember to search it yourself instead of asking me. Because in exam, that's not what happened, right? In exam, that's not what happened. So where's sodium?
Group 1.
Okay, now I'm going to put it there. Now, where is sodium ion?
It should be right on the other side of the mirror.
Yeah, and way down, right? Way down there, because you were way up there. So if sodium goes from sodium to sodium ion, imagine the drop. Now, the drop is a good news for him or for us or what?
It's good news.
For who?
For us.
Actually, not really, but let's talk about his perspective first. The presence of sodium metal, is it good news for him or not?
Isn't good news for us in a question, not literally.
So let's talk about his perspective, because we're studying metal now. Again, for sodium metal, good news for him or not?
Yes.
Why so, in his perspective?
Because he's selfish. Like, he's the most selfish, so he can win the most ions. Does that make sense?
No, no, not from his perspective. Why is he think that it is a good news for him to become sodium plus?
I mean, so it can be balanced.
Yeah, you can say that. It's his life goal to lose 1 electron.
Okay.
Right? So just say that. The greediness has nothing to do with this, not yet. Right? Okay, so where is aluminium?
Okay. It'll be the group 3.
Wonderful. Now, aluminium ion, where is it? Imagine.
Just 2 above sodium.
All right. And then here, let's say we go up low. So that means we have started from aluminium ion, no? Aluminium 3 plus into aluminium, right? Notice that the jump up is slightly lesser than the jump down of sodium, right?
Yeah.
However, if you compare it with the jump down of zinc, you will notice that zinc jump down less, correct? Yeah? Than aluminium 3 plus jumping down. And so the order matters. It determines how far you jump up or jump down. So far, so good?
Yeah.
Now, my last question, which is your homework, is do you remember? It was orally delivered. So do you remember?
I typed it out, no?
Right. So let me repeat to you. The homework. Okay? Let me repeat to you.
Okay.
How come the reaction with water happen automatically?
Mm-hmm.
Yeah, that's the question.
Because of the speed of the water molecules.
All right. I'll just use the reactivity series. This is a new perspective. Maybe. I hope it makes a lot of sense. I'm not trying to ask you to memorize something. I asked you to identify where water is in the reactivity series. That was my hint. Where is water here? Do you see water here?
No.
All right. Then you go back to the reaction that you learned in the, I think, 14.1. You look at the cold water reaction. Cold water reaction, wherever it is, cold water.
What should be 14.2?
Maybe search cold water or something like that. I don't know. There you go. Right. So look at this. So obviously the potassium is reacting with water. My question is, where's water, right? You don't know yet. Look at what happened. It becomes KOH and then hydrogen, H2. I want you to notice that you can identify where potassium is in this reactivity series. Where is it?
Group 1.
Yeah. And potassium becomes what? Very clear. Must be very clear.
Potassium hydroxide.
No, stop saying that. I know that's true, but that's you're not supposed to be amateur already in chemistry. You should say it becomes K plus because KOH implies that there's K plus.
Okay.
Do you know that KOH always implies that it's K plus? It cannot be the simple normal K.
I mean, yeah, obviously. All
right, then from K, it will become K plus. Where's K plus?
Can you see my cursor?
No, the K plus in the reactivity series line.
Oh, the group, so the reverse. So like where sodium was +2 or where aluminium is. Eh? No, sorry, where sodium was.
You're not making any sense.
Oh wait, let me retract my steps. Where sodium plus would be. So all by the end.
Good. So we'll call this the biggest drop, right? The biggest drop. When you drop, by the way, you release energy or you need energy. Now think about this carefully. I don't want it to be a memorization. I want it to make sense. The biggest drop in reactivity series. Will he release energy? Will he absorb energy? Will he don't care?
He will release energy.
All right. Let me put what you say in context. From a state of very unhappiness, into a state of extreme happiness, correct?
Mhm.
K release energy when he become from unhappy to happy. Makes sense or not?
No,
Why not? Tell me.
and it just logically doesn't make any sense.
So you're saying that it makes more sense from unhappy to happy, you absorb energy.
Yeah.
Okay, I would like to quote normal life experience to justify, which is obviously not a chemistry help. No, just normal life. If you're unhappy, you are settled or unsettled, just say.
You're unsettled.
Meaning to say, you want to either settle somewhere else, right? Or you just want things to change. That's the definition of being unsettled, right? Very close in practice to being unhappy. You want things to change, correct?
Yeah.
In chemistry, you react. In chemistry, you react like if you're unhappy or unsettled or reactive. So now back to us as a human being. If you're unhappy or unsettled, we want things to change. When we are happy, would you kind of, I don't know, equate happy with settle kind of ish? Maybe, make sense?
Yeah.
And then when you're happy and you're settled, you don't want things to change.
Mm-hmm.
Connection to chemistry, when you do not want things to change, you are stable, you're not reactive. So a stable thing in chemistry, we can relate to him. He is happy, he is settled, he does not want to change. He is stable. All right. And when he's reactive, he's unsettled, he's unhappy, and he wants things to change. Or rather, he wants himself to change. He just doesn't know that. He wants himself to change. It will manifest as changing other things outside. He himself will change. So far, so good, Ken?
Mm.
Now, back to the release of energy, extremely important. You are unsettled, you are very reactive. You contain a lot of energy, or you contain very little energy. Humanly speaking.
Very little.
If you're unhappy and unsettled, you contain very little energy.
Yeah.
You mean you're lethargic, I don't think that's what unsettled means. You're lethargic and you are energyless, you are feeling lazy, you don't want to do anything, right?
Does that not mean unsettled?
That doesn't feel like unsettled or unhappy. I suppose I would say when somebody is procrastinating, he's actually unhappy. But when people procrastinate, he doesn't realize that he's unhappy. He thinks that he is happy because he's procrastinating. I don't know. It's a very complicated feeling, like when we are procrastinating, I feel.
Yeah.
But if you are unsettled and unhappy, you don't necessarily procrastinate, right?
True.
You simply want things to change. I don't want things to be like this. Whereas procrastinating doesn't seem to mean he wants things to change.
Yeah.
Right? He may dream of things changing, but he's not acting like that. I will see the action more than the dream or the thing. So let's not equate unsettled with and unhappy with procrastinating or not doing anything. I don't think they are the same thing in real life. Okay?
Okay.
Back to my question. If you're unsettled and unhappy, do you imagine it as little energy or too much excess energy?
Too much excessive energy.
If you can relate to that. Okay? And when you're happy and stable, I don't mean when you're excited. Please don't equate happy with excited. This is happy, stable, content. Content, maybe that's the best thing. When you're happy, stable, content, do you have a lot of excess energy or do you have very little energy or extra energy, I would say?
I can see where this is going, so I'd say less energy, but I would have more energy personally.
Again, I would like to differentiate between happiness and excitement. I think they are two different things. Also contentment also. Maybe I refer more towards the contentment or the happiness one. Right? Okay. So back to chemistry. I'm trying to steer away from memorization. You're not very good at it. You cannot even remember sodium is group 1 until 4 times, which is fine. Which is fine. You have the periodic table, but you also cannot remember that you need to search it yourself. So, I have made the conclusion that it's better to talk logic than to memorize as much as you can. Right? Having said that, your memorization of reactivities is not bad. So there's always a hope. Now, when you're unsettled and unhappy to when you're happy, do you release energy or do you need to absorb energy?
When you're unhappy to happy,
Yeah.
Release.
And when you go from happy or settled or content to unhappy or unsettled, you need to
gain
energy. One last time. When you drop, you release energy or you gain energy?
When I drop, so
when the potassium drop to potassium ion lah, maybe that's what I mean lah.
Yeah, release.
Release, yeah. So everything makes sense visually, logically, emotionally. I don't know. That's what I'm trying to aim. Okay. Okay, yeah. So now back to the original question. You have K, you have K plus. He is releasing a lot of energy. Here's your K. Here's your K plus. The release of energy, everything matches. Everything matches. Exothermic means release of energy, correct? Okay. But my original question is not all this, right? My original question is, where is H2O and where is H2 in the reactivity series? That's my question.
I mean, there is hydrogen.
There is hydrogen there, right? And this hydrogen is hydrogen metal. Well, there is no hydrogen metal. There is not, right?
Yeah.
There is only hydrogen which has not lost or gained. Isn't that the definition? Yeah. Potassium metal is haven't lost, haven't gained. I know he just want to lose, but the point is oxidation state 0. That's the point. That's the point. So hydrogen gas oxidation state is
0.
Good. There you go. That's your hydrogen gas, if you can accept, because oxidation state 0.
Okay.
Oxidation state of H2O, the H, what is it?
The H of H2O.
Yes. Is it 0?
It's happy.
Is it 0? Then?
No.
What is the oxidation state of H then? You learn this. +1. Say +1. In this case, +1. How come he's +1? Let's explain.
It's because it gained the extra one from the other hydrogen. Like it's a bond. It's a covalent bond.
He gained a +1 from the other hydrogen. But totally does not make any sense. It just doesn't make sense.
No, like it's sharing. It's sharing. So not gain, sharing.
So because he is sharing, he gains +1.
Kind of?
No. Let's be clear. Let's be clear. This is H2. H2 is sharing, right? So why is the oxidation state in this sharing situation 0? I thought sharing means you gain or lose something.
I'm kind of confused now.
Yes. Now H2O. That's the form of H2O. Remember that. H is sharing with who?
O.
The greediest?
Yes.
So let's repeat the logic again. The oxidation state in H2O is not 0. You're right. It is +1. This is +1, +1. This is -2. Why? I know teacher don't teach this. Do you remember what I said? Because O is a greedy bastard for what?
Yeah, that I know.
For who? For who? O is a greedy bastard for what? For what does he desire? What does he want?
He wants to lose.
You see minus, you say lose. Everything.
Oh, sorry. He wants to gain. He wants to gain. He wants to gain.
He wants to gain whose electron?
Hydrogens.
Other people lah. In this case, hydrogen. Other people's electron. And H is not a greedy bastard. They don't tell you this. I tell you this. So what happens to the sharing relationship of H2O?
It's very unbalanced.
Very good. So therefore, oxygen uses almost all the electron, and H, let's go lah, almost lah, almost. It's almost like that. What's the oxidation state of H as a result?
Plus one.
Plus one. Now back to the original question. What's the original question?
The sharing of hydrogen.
No, where is what in what?
What?
Where is H2O in the reactivity series? That was the original question.
Oh, yeah.
Where is it?
It should be up here somewhere.
Everybody on top are people or metal or ion which have not lost or gained electron. Oxidation state 0. Where is it?
It'll be on where H2 would be.
H2 oxidation state is?
Plus one.
0. 0, 0. I keep telling you the one on top haven't lost or gained electron. Everybody's oxidation state is 0 on top. Yeah. On the half mirror on top. Stop pushing H2O there. The oxidation state of H in H2O is?
1. Plus 1.
Plus 1. It's not 0. So it's not on top. It's not. Yeah. Where is it?
It'll be 4 from the bottom. Like, sorry. 4 from the top of the mirrored image.
Correct. Top. Here is your H2O because it is plus 1.
Yeah.
The original of the original question. How come potassium react with water? How come? Look at this diagram.
How? Because I still don't know the answer.
Because potassium jump down so much and H plus only jump up that much. The jump down is bigger than the jump up. Is this the first time we talk about this jump up, jump down thing?
No, but it's the first time we talk so like abundantly about it.
Yeah. And I'm trying to explain this reaction with cold water in a way that makes sense with the reactivity series. Okay, now let's ask the question again. How come sodium react with water? You explain using the reactivity series.
Because the sodium jumps down so much using down the reactivity series. So it can react with water.
Yeah, because water simply wants to jump up, right? Or rather, water is forced to jump up. Water do not like to jump up, but is forced by the sodium. And that can happen because the jump up, jump down is better. So predict for all the metal on top from group 1 to gold, right? That's all the metal on top. Is there any particular metal who will never react with water?
Yeah.
Which one?
Iron and gold and copper.
Okay, let's start one by one. You say iron. Here's iron, right?
No, iron. I mean silver.
Oh, sorry, what do you mean? Yeah, which one?
Silver, gold, copper, the metals.
Very good. Why not? Why won't they react with water ever?
Because they can't force the water to go up because their jumping is smaller than the water's jumping up. You have to have a bigger jumping.
Something like that. Thank you very much. You seem to understand something. That is the general basic meaning of things. Okay. Any questions so far?
No.
Right. So it'll work with the hot water. Hot water is just water which is easier to react, right? It'll work with HCl also. Now let's go to the HCl reaction. Let's see what HCl reaction looks like.
This one.
Right. So my question, the original of the original question, how come HCl react with metal? Look at what happened to HCl. HCl is from what to what? Yankin, I can see you. Yes.
Yeah, I know. HCl is from
what kind of H to what kind of H?
From a happy H to a sad H.
Which is Tell me the appropriate name of happy H is H plus, right? I was waiting for you to say H plus, right?
Okay, okay.
H plus to, well, H2, which is oxidation state 0, which is a jump up.
Yeah. So the jump down is bigger.
Correct. So is there any particular different reason why, metal react with dilute hydrochloric acid?
It's the same reason.
Correct. Exactly. And they won't tell you the reason. They just ask you to memorize.
Okay.
Will copper, silver, and gold ever react with acid?
No.
Ever. Yes. Now you know why they're called precious metal. Now you know.
Oh, okay. I did not know that. Okay.
I'm not saying that copper cannot though. There are many ways to react copper with acid. There are super acids. But we never talk about super acid in O level. So we don't care. We pretend in O level, copper, silver, and gold will never react with acids because we only deal with strong acids, not super acids. This is in case some smart aleck tell you, yeah, but there are acids who react with gold. Yes, correct. It's called super acids. It's a mixture of sulfuric acid and nitric acid, 3:1. Anything dissolved in that acid. Who cares? That's not within your syllabus. Within your syllabus, we will pretend with reasonable reason that copper, silver, and gold never react with acid.
Okay.
Yeah. Because reactivity series. Okay. Right. I hope I didn't ask you to memorize that. I hope I'm giving you some sort of understanding. Okay. Now, let's go. You're going to find the next reaction they give you. And we're going to understand that reaction using reactivity series. Please, you scroll down slowly until you see the next reaction. Stop. This is the next reaction. Look at this. Explain why this reaction happened using the reactivity series.
Copper is being forced to jump up, and the iron jump down is bigger. That's why.
Tara, finish. Happy then? The exact same reason, isn't it?
Yeah.
The exact same reason. Now let's go down. Find the next reaction. Thus there's no reaction. Thus there's no reaction. Look, what happens if we add copper to iron sulfate? Thus there's no reaction. Explain.
Yeah, they explained it. It's the exact same reason, but the opposite.
Yeah, you tell me using the jump up, jump down.
Okay, so the copper jump down is smaller than the iron jump up, and you have to have a bigger jump down to convince the jump up to happen.
Yeah. Tara, finish. Good. Finish that. Okay, now, next one. Next new reaction, please. Is this new?
No.
Okay, then next one. Metal and the oxide of another metal. Is this new? Think about it.
Not really.
Explain then. Still, you can explain it, right?
Yeah.
How come this thing happened? It seems that it happens, so how come?
Because zinc's jump down is more than copper's jump up.
Yeah, finished. Right. Good. Metal oxide with hydrogen. Let's stop here. Is this new or not? Is this new or not?
I mean, it's the same concept still.
However, on top, we start with water becoming hydrogen. Correct? Now this is hydrogen become water. Be careful, right? So is this new or not?
No.
If it is not new, then you can explain.
Wait, sorry, it is new. Wait, what?
Okay, then try to explain.
How did the water go down and convince the lead to go up? The lead is above the water.
This is super weird, but let me explain.
Yeah.
Because even though lead looks like it is on top of hydrogen, right? But lead is super close with hydrogen. And therefore, the reverse can happen.
Oh, so you have to memorize this?
Yes, only for lead. The rest still works. So there are always exceptions. Their distance is not exactly uniform one. They are not. This is by experience. No, this is by experiment.
That was the biggest distance.
Surprisingly, there is super big distance between iron, Fe, and Pb. There are so many metal in between. One of the reasons why we cannot imagine this is because there are so many metal emitted. Right?
Yeah.
Fe and Pb is very far from each other. There are maybe at least 6 metals in between, 6 normal metal that we could know already, but they don't care. Just memorize this. That's what they say. No?
Okay.
Right. So this is a little bit of memorization. It is a weird thing. Remember it as a weird thing. Go up one slide. Just to check. Oh, no. Okay. This one. New or not? You were scrolling too fast.
Reduction. We learned this, oxidation and reduction.
This is new or not in the slide?
Multiply to reduce. What? What is?
I did promise you that carbon and hydrogen will become important, right? Hydrogen has proven itself to be important so many times, correct?
Yeah. This
It is
doesn't
not matter, but it's so now carbon, it's time for carbon to prove its worth. Why is it stuck here? Right? Is this like an anomaly or is carbon an important thing? Let's start with this slide. Explain the reaction between copper oxide and carbon. They don't even write for you the reaction because they're going to write down there, maybe I can see. So make a guess. What will happen in copper oxide and carbon? Something will happen.
Logically,
Yeah.
Nothing happens.
Why?
Because copper's jump up is smaller than copper oxide's jump up is smaller than carbon's jump down.
Yeah, that you're making any sense already. Right? The jump down is bigger than the jump up. Then something should happen. Wow.
Yeah, sorry. My mind is gone. Yeah.
Keep it. Don't lose your mind. Then. So again, should it happen?
Yes.
You can even argue that the jump down is very big compared to the jump up.
Yeah.
Now, it is not good news for copper because copper likes to stay copper oxide, right? Not good news. Carbon, to him, is good news. Carbon will become carbon dioxide, just for your information. Same problem. You have oxygen. Oxygen is a greedy bastard. Oxygen take electron from carbon. Carbon becomes carbon 4+. There you go. You find it below. Okay?
Okay.
So now think about this for a while. To copper is not good news. To us, is it good news or not that copper jump up?
Sure. I mean, doesn't matter.
No, it matters. It matters. No, seriously, it matters. You want copper oxide or copper? Practical real life. I'm not talking about
Copper.
price. Okay, why do you want copper more than copper oxide?
I don't know, for more use, like wires. I don't know.
Yeah, all the wires in your handphone or the iPhone 14 that I hope you get, iPhone 14, sorry, with the wireless charging, the rounded magnet wireless charging, the charging part is made of copper. Okay. You want copper more than copper oxide. So to copper, jumping to copper oxide, jumping to copper, I mean, is bad news for him. It is good news for us. Can you relate that? We react to different things. We have a different perspective than the metal.
Okay.
Now, iron, Fe, iron oxide, iron. Who's happier?
Iron is happier.
So when iron oxide meets carbon, will he become, unhappy?
Yeah.
Is that good news or bad news for us?
Good news.
Because?
Iron is also useful. You can make I don't know, cooking stuff with iron.
Yeah, a lot of things in your house made of iron. Now, think carefully. Yeah, we are losing carbon in the process. Carbon becomes carbon dioxide.
That's good as well. I mean, actually, no, it's not good. But...
It's not good. But we still prefer the iron, right? Compared to the carbon. Carbon is simply coal, correct?
Yeah.
So
coal isn't good either.
The coal disappeared to carbon dioxide. Also not good, right? I noticed that global warming.
Eye for an eye.
However, if a nation want to grow, let's say India, you have to relate to India a little bit, not Singapore. Singapore don't have coal power plant because we can afford to burn oil. It's not better in any way. It's just less dirty. Now let's relate to India and Indonesia. I relate to Indonesia, you relate to India. Okay?
Yeah.
Can you afford to ask India to not sacrifice coal for the sake of iron?
No, I mean there are still trains which use coal, you know. I've been on them.
All the time.
Yeah.
All the time. In Indonesia, slightly less. Same thing one. If I have, by the way, Indonesia have a lot of coal and have a lot of iron oxide. We have a lot. Can we afford not to sacrifice, carbon, coal for the sake of more iron?
No.
Because we're growing. Same like India.
Yeah.
So we will make that trade even if it means global warming. That's economic law.
Yeah.
Right. Back to chemistry law. We don't care that iron becomes unhappy also. We don't care. We want the iron. And we don't care that carbon becomes happy. Good for you. Good for you. We care that the planet is become warmer. Unfortunately, we care more to have more iron. We need the more iron to build stuff lah. Stuff lah. Really stuff lah. Really stuff.
Yeah.
Right. So that's chemistry, economics, and whatever happens. Understand this new reaction?
Yeah.
The basic is still the same, right?
Yeah.
Let's scroll down for more new reactions. Is this new? Oh, this is not. This is. Just take note on this first. This not on this first. This is a weird one. This is a weird one, which will be important. Okay, take note. We haven't explained or understand this. Okay, right. Let's go down.
Let me take a screenshot of this.
Sure. We haven't explained this. What the heck is this? All right. Okay. What is it, man?
No.
Okay, you can put it on the Jamboard. That's one way to organize. Put a question mark. What the heck is this? Now, good news on this slide, there should be no more new types of reaction. Everything that appears up to now will be a variation of what we talk about. In the end, it's still jump up, jump down. In the end, right? So I'm willing to bet 14.3 using the never mind. He's just trying to explain that. We're gonna pretend that this doesn't happen for him. Right? Go down. Right? Using the reactivity. This is your homework. Usually with homeworks, we read and analyze first before you do it. This is your homework, okay? Plus the math one. Please read this. Let me explain to you whatever you don't understand, and then we will end for today.
Okay. There's a lot of words.
Definitely. A lot of words to understand something.
Okay, but before this, I don't think I'll be able to do tuition from 8:30 on Sundays.
It's on 9, makes sense.
Yeah, because I mean, even from 9 to 10, I'm already quite tired. But there's no way I will be able to do from 8:30.
Why are you tired on Sunday, the start of the week? That's the part that I don't understand.
Oh no, it's because I go to badminton for like 2 hours plus, and then I come back really exhausted.
I like the physical aspect. I like that you will sleep after this. That's why I like it. Right. So I'm willing to put up with it. If you're willing to put up with it, just 1 hour, and you will still force yourself to think, but you are tired for a good reason. If you can put up with it, I will put up with it.
Okay.
Right. Then no change. No change. Right. Okay. I like the reason. I really like it. Okay. I like that you're tired for those kind of reasons. Now read this question. Bear with it.
Reducing the order of your receiving reports.
Just to be clear, you do not know who is PQRS, right?
Yeah.
So the reactivity series doesn't seem to be helpful. Like P is not lead. No. S is not sodium. No, it's not. It's just don't know who.
Is displaced.
Now, what does displaced mean? You must think about it carefully.
Means it got shot up.
It goes up or goes up, sorry?
It goes up.
You are absolutely correct. You are wonderful. I like you. Just now, I like you.
Yeah.
So P goes up in figure 1. That implies what?
S is higher up on the hierarchy scale.
S goes down also. And that's why.
Yeah.
Oh, I like you even more just now. Just for a while, I like you even more. P goes up, S goes down. You already know the relative order between P and S.
Yeah.
Very good. Why don't I help you? Since I like you, I will help you. Here is S. And here is P, right? That's what you're saying, correct?
Yeah.
The P plus will be below, S plus will be below. Who cares? Now, figure 2.
Q is like
Q
P is above Q.
So I put Q like that. Something like that?
Yeah, then you're done.
Okay.
Oh wait, no, that's not Q is above R, so SPQR. Rule.
I will leave it to you to think about it. You have an answer. Tomorrow you tell me the final answer. Here is a piece of good news. I hope it's a good news to you. This shows up in exam every time.
Okay.
Right, Yankin? You're the senior. Correct?
Sorry, I wasn't.
Order of reactivity of metal. This is later. This is later. Always happen in exam, right?
Pretty much, yeah.
Yeah. Thank you very much for your input, senior. Okay, good. You have your homework. You will do it yourself for math. Check yourself. For your chemistry, this is your homework. Okay. Are you surviving?
Surviving. I'm very
This 1 hour. Oh yeah, but you seem to answer it well within some reasons. You seem to answer it with reason. I don't know.
it's because I'm just gonna sleep after this.
Oh, very good. I like that a lot. I like it.
Yeah.
Okay. I will see you tomorrow with the homework.
All right. I'll see you. Bye.
Good job. Bye-bye.
Good night.
Yes, Yankin.
One question.
Yes,
I'm gonna
please.
put
Ask me.
because I'm.
Show me what you want. Show me what you want. Right. Okay, I'm gonna at least take a picture. Yeah? You help me. Yeah? Okay, got it. Okay, I'm not sure what is this. I'm gonna take it. Right. Okay, I'm gonna put it in the Jamboard.
Yep. My issue is with part 5 of the question, but you need extra knowledge.
Extra knowledge. Why do you?
Extra context. Sorry.
Why do you assume that? Sorry.
Because they say so.
In the answer key, you mean?
No, in the question, like part 5, they say right there.
Okay, sorry, I'm still, part 5. So during heavy exercise, okay, in the lung, blah, 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 right? During heavy exercise, like good. Define the buffer, no problem. Use the data above. I will leave you to that. Use the right equation. Y has no. This is just the balance. Good, right? Then part 4. Are your question is part 4 or part 5? Sorry.
Part 5.
Okay, with hands by good. Now, the student wishes to simulate the blood pressure buffer, but good. Yeah, good. And that makes sense. The direction that is represented by that. So using your answer in 2, isn't it? Okay, good. Then calculate the volume. No. Okay, good. So why are you concerned here?
So I have the ratio from part 2, right, which is 19.844.
Okay, great. And then?
So using the concentration of H2CO3 from the question, which I think that's how you use it.
The reaction with, by mixing this and that, right?
Yeah, then I got 3.9688 for my concentration of HCO3 minus.
Oh, okay.
But okay, after that I calculated the number of moles of H2CO3
remaining.
Originally, I'm not sure if there's a remaining.
That doesn't make sense. How come the original is this? Oh, the concentration, what? 0.005 mole divided by how many volume, right? That's just amount, that's not concentration.
Oh, amount of H2CO3.
Yeah,
I'm not-
but you need to compare concentration. No.
Concentration.
Yeah, the ratio on top there is a ratio of concentration over concentration.
Yeah, I already did that. So this one is 19.844 times 0.2. I'm not sure if that's the concentration I'm supposed to use for H2CO3, but
The concentration of H2CO3, you know. Yes, you know. Wait, what? Oh, yes, they do give you. I'm so sorry. I'm not talking about they do give you. Which actually the concentration will change totally, right? The reason is because the 0.3 NaOH, of course, there will be neutralization, but is it guaranteed that it is a titration? That means both, both gone. Is that a guaranteed thing?
I'm not sure. I don't.
I shouldn't assume that, right? The 0.3 mole NaOH, you need to know the volume, right?
Yeah, which is what I'm trying to find out.
You're trying to. Oh, I'm so sorry. This neutralization. This is exact. No, this is exact titration because volume that should be added. That means there's a goal. There's a goal to just neutralize everything, right? There is a goal. That's a goal. So the OH is gone. That's the whole point, right? The OH is gone, but you will have some remaining H plus, which will then reversible balance with H2CO3. That was the point. Yeah, that was the point. All right. Now, so following, wait a minute. The original concentration of H2CO3 is 0.2. Very, very soon that disappeared. Very, very soon that disappeared. Oh, no. The original concentration of H2CO3 is 0.2. You cannot use it here. This is the concentration of H2CO3 when you achieve the reversible balance.
Oh.
You can't. Anyway, when you add more, other solution into it, the 0.2 already doesn't work. So you cannot do that. You cannot do it. Yeah, okay, that's the problem now. Oh, that's your question now. That was your question.
Yeah, okay, but then where do I proceed from here? Because then I assume I'll have the amount of
So neutralization assumes that again, you will have 1 mole ratio NaOH and 1 mole ratio H2CO3 lah, and then 1 mole NH. Maybe you can start from there, right? Maybe you can start.
So there'll be a new volume, right? So it'll be the 25 cm³ plus X, which is whatever the amount of NaOH is added.
At least that we must assume, right?
Yeah.
At least that. Right? But I think noting that the amount of H2CO3 first is that the amount of HCO3 minus that was created, and then they will rebalance, right? HCO3 minus will decrease, which will make more H2CO3, right?
Yeah, but is that when I use the ratio?
No, I think you just use it between the original H2CO3 0.05 mole. Okay, everybody can agree with that, right? Plus the original NaOH, I suppose, right? Plus the original NaOH is going to be also 0.005 neutralization, titration, neutralization. I think we should just go there first. Then the amount of HCO3 created, definitely that, right? It doesn't mean that H2CO3 will all disappear, right? It doesn't mean that, because some will be created by the rebalancing, right? But we can safely say that all the OHs disappear. The NaOH, the OH from that will all disappear.
Hang on, wait. All the OH from the NaOH will disappear. Yeah.
Correct. But, and that's the, I think that's the original goal, right? That's the original goal.
Hang on. Can you repeat what you said?
Let me put it another way. Let me put it another way. Show me the go up a little bit. I think you wrote the reaction. Let me see. Yeah, that's
that's for part 3.
no, that's not part 3. No, that's not part 3.
The reaction.
What's your part 2 reaction?
Part 2 reaction.
The question gives it because just
this is just the buffer equation from my notes.
Okay. So you don't you don't write the reaction, but I guess you can apply the formula that way, right?
I don't. No. I have a reaction of H2CO3 and like HCO3 given minus. Here.
But it's given. Where is it? Where is it?
Oh,
just to confirm. Right, just to confirm that they give you. Wonderful. Yeah, so they do give you that. That's fine. That's totally fine. I can copy that. Right. Because in case we want to talk about it, and then I assume that you know, then you don't know, right? Not good.
It's a bit blurry.
Right. So it's given. Oh, it's good. Good. Wait, yeah. Everything. Please do something else first. I have to confirm something. Because I don't understand the question. Yeah. Right. Yes. Yeah. Right. Right. Correct. Yeah, the ratio is quite high, right? Yeah. Can I confirm part 2 ratio is quite high, around 17?
That's like 19.
19. Okay. So, like he's saying that 19.1. So he's saying that the H2CO3, okay, that makes sense. Right? So the H2CO3 is not a lot, right? Yeah, that makes sense. Yeah. Okay, good. So we'll put this as X. Put this as, so the remaining will be 0.005 minus X, right? For volume. And then this will be X. For volume, this will be 98.1. Right. Okay. Right. So apologies, it took some time. Right. If I can explain.
Yes, sure.
Right. So no, I take back my word that NaOH should completely react with the 0.005. Right. I believe it should be slightly less. I don't think it's slightly more. More, no point. More is just the same as spending everything. Right. Just it. Right. So since I do not know that, because I take back my assumption, oh, they should be the same. No, I don't know. Okay, then I just put it as X, correct? That's all. X can be 0.04, 0.35. I don't know. The point is, it's less than 0.05. So far, so good?
Where is the X?
The X is here. So my NaOH is X, right? My
Okay.
H2CO3 is 0.05. Of course, I know that. Okay?
Yeah.
Now, if it is X, then there will be some H2CO3 remaining, right? So it's very simple, right? The H2CO3 remaining is 0.05 minus X. Simple, right?
Yeah.
Right? Of course, I'm using the ratio 19/1 concentration. So just over volume. I don't know what's the volume. I don't know, right? Remember, I don't know. Now, on top here is the, the concentration of HCO3 minus, which is created, right? How much is created? X.
Yeah.
Of course, over V also. Okay, then my V is no longer a problem.
Oh.
X over this equals to that, math X over. This is a common thing to happen, by the way. I hope that you will prepare this for.
I got tricked on this during prelims, so I want to ask it.
Right. Prepare to do this tomorrow. Prepare tomorrow. On Wednesday. Can I erase what I did? You try yourself.
Me.
Okay.
Yeah, you can.
So that you're not confused. So that you're confused. Note that I make our thinking simpler by saying what I don't know, right? Or I don't know the volume, or I don't know the mole. Okay, yeah, we can start like that. We can. It's okay to do that. You lead somewhere anyway. Right? Then you can check this whether it's correct or not.
Yeah, I'll need to pull up the OV paper.
In case there's some problem, I'll see you tomorrow. But if this is correct, again, remember to be prepared for this.
Yeah, I'll look for more questions like this.
But I know tomorrow I have no exam, but maybe after a while you should sleep for now. Right?
Yeah.
All right. I'll see you tomorrow.
All right.
There is no other question, actually.
No.
All right. I'll see you tomorrow.